On today's class. So what we're going to be doing today is we are going to take a look at continuing on with the t-test. Chapter 8 is the introduction to the t-test, single sample independent means. We are still going to stay with the single sample today. But before we get to that, just a little bit of an update on myself and the little bit of craziness that happened last week. So as you hopefully have seen from the announcement, I suffered a concussion last week. So this is video from my bike ride in to IUSB, and it's a little sideways and then not so much sideways there. So that was when I wiped out, taking a turn that I have literally done like hundreds of times before. So I think I slipped on the leads that were there when I was taking that turn. That was some of the damage as a result of the crash. There's a little bit of a more close-up on it. Included was a black eye, but worst off was the fact that I did suffer a concussion. Ended up going to the ER. They did a CT scan. There was no fracture. There was no bleeding in my brain. However, I was diagnosed with a concussion, and one of the weird things that comes out of a concussion, and hopefully not many of you know this, is there is memory loss. So from the time that actually from before the time that I crashed, I don't have memory of this particular incident. So when I showed up to work that day, I did not know that I had crashed on my bike. I had no memory of that particular event. From just before that crash up until the time I was in my office, I have no idea how I got to my office that day. And I really don't remember any of the details about anything from the crash other than what I was just happened to be filming with my cell phone. I have a little cell phone attachment for the bike. And I literally have no memory outside of what I viewed on that video of the event. So on that note, when I was looking through the video, it was a little bit like a found footage horror film where I had lost time and I was like, oh my gosh, is this what happened to me in the forest? But on the positive note, I would like to point out that I was helped by somebody. So somebody actually stopped, and I heard audio in the video, in the recording where they were like, are you okay? Are you all right? And this particular individual actually stopped and helped me get back up and grabbed my cell phone, snapped off, the attachment. They put it back on and they, got me back to my feet. So I have absolutely no recognition of this individual. This is all I have on the video. So if you see that hair walking by, or just to kind of put this out into the universe, this person helped me out. So thank you very much for whoever that hair belongs to. But as I mentioned, I did suffer a concussion. I have no conscious recollection of even receiving help. I have no idea how I made it into school that day, how I ended up in my office. So I went to the ER and I got diagnosed. I indeed suffered a concussion. And one of the things that the doctor prescribed, and this was new to me, I'd never had a concussion before, was brain rest. And for 48 hours at least, so I extended it a little bit longer, you have to do what's known as brain rest. And brain rest includes no sports, no schoolwork, and then this is massively challenging, no screens. So no computers, no TV. I broke the rules a little bit just to put up the announcements, that classes were canceled. But try to adhere to this as best as I can. So if you didn't receive any word from me at all last week, this was the reason. I was giving my brain time to rest. And thankfully, I'm recovering nicely. Thankfully, my memory loss is very prescribed to in and around the actual time of the incident. I haven't lost days. I only seem to have lost, about an hour or so. But I would like to just put one final little public service announcement. So that was the extent of the injuries to my head after my crash. So as far as I can piece together, I took the turn, I slipped on leaves. I think my head hit the side of the curb. So that was the damage that occurred, and it would have been way worse if I wasn't wearing my helmet. And as you can see, my helmet is actually massively cracked in a number of areas where it took the brunt of the impact. And the reason I'm mentioning this is because I've seen so many articles after this incident. You know, I've been investigating getting a new helmet. And I have looked at so many articles where people have said that, you know, they never wear helmets when they're cycling. What's a helmet going to do anyway? If you're in a collision with an SUV, you know, a helmet's not going to help you. So to paraphrase Jerry Seinfeld, if you're ever in a collision with an SUV, your bicycle helmet is now wearing you for protection, right? So it's not going to be effective whatsoever in like a high impact collision. But it is important to wear. And I am a very experienced cyclist. I've been cycling for years. I've been commuting to work for years. I have taken that turn hundreds of times, that specific turn. I've gone that path in the middle of winter, right? When there's ice on the roads and I'm there with my spiked tires. I have taken that turn hundreds of times and I've never even so much as wobbled. And this is the time that I actually went down. And thank goodness I was wearing my helmet, because that fracture right there is not a fracture on my skull, and I would have been in much, much worse condition, and my skull for sure would have been fractured if not for the helmet. So if you're a cyclist or if you know somebody that doesn't wear a helmet, yeah, it's not going to help you in a high impact collision with an SUV, but on a regular fall down like what I suffered, I'm here today because I was wearing that piece of plastic and styrofoam on top of my head. All right, so that's just kind of an update in terms of what happened. Yep. No, it actually happened. It was on Twickenham and Ruskin is the intersection. So on my way to school, but yeah, not on school property. But again, that's just from the video evidence. I, did not actually remember where it occurred. But yeah, that's currently, the situation and where we're at. So on that note, I have had to update the syllabus, update some of the due dates because we've missed a week. So I've uploaded that to Canvas. Please download the new PDF, the new syllabus, check the new due dates. I've moved stuff in on my lab as well. I've changed the due dates for upcoming things on my lab as well. So double check with that so you can plan out the rest of your semester. And also note that in order to make up for the week that we lost, much like when I was at a conference and we missed a class and I had an online only class, we're going to be doing 2 online only classes in addition to our regularly scheduled classes. So there will be 2 Fridays when I will record an online only class. I will post it to YouTube, and then sometime before we meet again on Tuesday, so either the Friday, the Saturday, the Sunday, or the Monday, please try to watch that so that we can catch up on our semester. And I'll try to limit it to days where we have minimal in-class practice. So again, check the schedule, check the new syllabus for those and for the new due dates as we kind of continue forward and try to recover from this unfortunate incident. All right, so as we saw last time, we are now ready, you are now ready, you now have the skills to do all 5 steps of the hypothesis test on your own. So you can form the null and the research hypothesis. You can determine the characteristic, the comparison distribution. You can determine your cutoff scores. You can calculate the t-score for your sample mean. And then you can make the determination, step 5, do you accept or reject the null hypothesis? But we are now getting to the point where, because we're incorporating real situations, real life, real psychology, that the examples and the procedures are getting a little bit more complicated. And because of that, it's time to stop doing these things by hand, and these calculations by hand, and start to use the specialized statistical programs that are in existence in order to help us do our statistics hypothesis testing. So it's time for SPSS. It's time to turn over all the heavy lifting in terms of math and calculations over to the machines, which puts the responsibility of two things heavily on our shoulders. So the two things that we are still going to need to do is, number one, choose the correct hypothesis test and format the input correctly for SPSS. So we're going to have to figure out what SPSS should do, and then we're going to have to put the data into a form that SPSS will be able to analyze. Then what we're going to see is we're going to allow SPSS to do the heavy number crunching and the heavy mathematics. And finally, when SPSS gives us its output, it's going to be on us to correctly interpret that output and figure out whether we should reject or accept the null hypothesis. So last time when we introduced this, we took a look at Harlow's study on monkeys. Today we're going to revisit that study one more time, but this time we're going to not do the calculations by hand. We're going to do SPSS instead. So we're still doing a hypothesis test with the t-statistic, that idea that we introduced about 2 weeks ago now. But today we're going to start using SPSS to actually do the t-statistic, and then we'll have some time for in-class practice. Now, before we get into SPSS, just so that you're absolutely sure about how to access this, in terms of here at IUSB, most of our computers, especially in these computer labs and in the psych lab, will be pre-installed with both Excel and SPSS. So if you're upstairs in the psych lab, you can just log on to it using your IUSB ID, and SPSS will be there for you to use. So if you can do all of your homework here at school, that's a great resource to use. If, on the other hand, you need to do some of your homework at home, just know that you also have access to all the resources that you need in order to do this work at home. So if you do not have Excel at home yet, I would highly recommend go to IUware and download. You can get a free copy, a free license for Excel to install on your computer that you can use for free as students here. They paid your subscription fee. But more importantly than that, SPSS is available, but I want to be very sure that you know the correct way to access it. So SPSS is available, but if you want to install it on your home computer, you will have to pay a subscription fee, and that subscription fee, I believe, is $55 subscription. However, there is another alternative, which is to use IU Anywhere. And in IU Anywhere, you can use SPSS for free, no subscription fee. And the reason is because you're not installing SPSS on your home computer. It's installed on a server that is here at IUSB, and they've paid the subscription for people to access the server, i.e. for students to access it. So you don't install it on your home computer, you access it through the IU Anywhere streaming service. So if you haven't already installed IU Anywhere, I highly recommend get that installed. It can be a little bit finicky depending upon your computer, so you might have to stop by the IT help desks over here to iron out any final issues. But with that IU Anywhere, you can use SPSS on your home computer for free. So at 2 in the morning on a Sunday night, if you're trying to finish the last of your homework, you can do that, and you don't have to get any more out-of-pocket cost to access SPSS. So I just want to make sure everybody is aware of that option. All right, so back to the hypothesis test with the t-statistic. So we saw this last time that we met. Just by way of a reminder, in that classic study of infant attachment, Harlow placed infant monkeys in cages with 2 artificial surrogate mothers. One mother was made from bare wire mesh and contained a baby bottle from which the infants could feed. The other mother was made from soft terry cloth and did not provide access to food. Harlow observed the infant monkeys and reported how much time per day was spent with each mother. In a typical day, the infant spent a total of 18 hours clinging to one of the two mothers. If there was no preference between the two, you would expect the time to be divided evenly with an average of 9 hours for each of the mothers. However, the typical monkey spent around 15 hours per day with the terry cloth mother, indicating a strong preference for the soft, cuddly mother. Suppose that a sample of 9 monkeys, infant monkeys, averaged 15.3 hours per day with a sum of square deviations of 216 with the terry cloth mother. Is this result sufficient to conclude that the monkeys spent significantly more time with the softer mother than would be expected if there was no preference? Use the two-tail test with an alpha of 0.05. So this time we're going to do that exact same experiment. However, we're going to be using SPSS. So even though we're using SPSS, the 5-step hypothesis testing procedure stays the same. And some of these things we actually cannot do with SPSS. So for example, step 1, restate the question as a research hypothesis and a null hypothesis about the population. SPSS will not do this for us. We still have to do this on our own. So we want to know, is there a preference for the terry cloth mother or for the wire mesh mother? Our research hypothesis is that there is a preference for one of the mothers, which means that the mean time spent with the terry cloth mother does not equal the mean time spent with the wire mesh mother. And because they're spending 18 hours a day with one of the two mothers, that means that the mean time spent with the terry cloth mother does not equal 9 hours. So if that's the case, then the monkeys that we have belong to this treated population that has an unknown preference for one of the mothers. It has an unknown time that it spends on average with one of the mothers, but we definitely know it's not going to be 9 hours. They're not going to split the time up evenly. That's the research hypothesis. Hasn't changed since last time. The null hypothesis also hasn't changed since last time. Null hypothesis is that there's no effect, there's no preference for either mother. And we write that as the mean time spent with the terry cloth mother equals the mean time spent with the wire mesh mother. And because they're spending 18 hours a day with both of these, that means that the mean time spent with the terry cloth mother would be 9 hours. So they're spending 9 hours with terry cloth, 9 hours with the wire mesh mother, 18 hours in total. And if that's the case, then they belong to this hypothesized population of monkeys that spends 9 hours with the terry cloth mother. So that's step 1. We've seen that before, hasn't changed. Step 2, determine the characteristics of the comparison distribution. Thankfully, SPSS will do this for us. So determining the characteristics, SPSS will do those calculations. What we need to do is we need to know where to look for those numbers and how to read it off of SPSS's output. Step number 3, set a critical sample score or set a cutoff sample score or critical value. SPSS will do this with a small little shift. So that setting a cutoff sample score or critical value, SPSS will do this for us, but we are going to make a small little slight change. Step 4, determine your sample score on the comparison distribution. So where is your sample on that comparison distribution? SPSS will do that as well. And then step 5, SPSS will not do for you. That is still up to us. So with that being said, step 2 to 4, we're going to get going on SPSS. The data for this can be found in file 21, practice, October 30th, chapter 8, introduction to the t-test XLS. So if you haven't already, open up Canvas, open up that Excel sheet. We will need that to move forward. And then just so that you know, we will be recording this so that you'll have a kind of like live feed of the SPSS work that we do. But also in your lecture notes, there is screen grabs of SPSS and what we will be doing. So you can also refer to those as well. So the first thing that we need to have is we need to have our Excel sheet that has the data that we are looking for. So before you can use SPSS, I'll zoom in here, you need to actually have the scores for each individual subject. So unlike previously, where we could do our hypothesis test when we were doing this by hand, if we just had the mean and the sum of squared deviations, to use SPSS, to use it as a program, you need to have the individual scores for each of your subjects. So we need to know how long did monkey number 1 spend with the terry cloth mother. In this case, monkey number 1 spent 17.2 hours. Monkey number 2, 19.09 hours. Monkey number 6, 13.40 hours. Monkey number 8, 9.61 hours. So we actually need to know how long did each monkey spend. We need those individual scores. We need that individual raw data. So the next thing that we're going to do is we are going to open up SPSS. So, no, I do not have it installed on my computer. So I'm actually going to do this using IU Anywhere. For your computers, you should have SPSS installed. So if you want to search for SPSS, you should have that installed on each of your computers. If you don't, and for when you're doing it at home, I'm going to do it through IU Anywhere. So if you just Google IU Anywhere, it'll take you to this page here. You can log in. Send me my push. All right, and it's probably not going to be in your favorites. So what you can do is you can go to apps, and rather than going through categories or just scrolling through all, if you just search for SPSS in the apps, it will bring up, oh, it's got 25. All right, we're going to use 24. It's got this IBM SPSS Statistics 24. SPSS Statistics 25 will be fine as well. That should be the newer version of it. But we're doing this live, so I'm going to use the one that I know works. So if we click on this, it'll start running on your IU Anywhere. It'll open up your Citrix receiver. And in just a moment, SPSS will begin. So was everybody, while we're waiting for my version to open, was everybody able to open SPSS on their computers? Everybody got it running? All right. Yep.
What does it look like on one of these computers? I can't find it.
If you just go to search, I just type in SPSS. Yep. All right, sweet. So it started up. Okay, so this is SPSS, and the first thing that pops up is this dialog box here. And this dialog box is usually used for more advanced things. If you've been working on a data set, you want to reopen a data set, those kind of things. But one thing that I do want to point out is down here in this Getting Started section, they have Get Help and Support, and also importantly, Get Started with Tutorials. So SPSS has a ton of help that is either available through the program, or it's one of the most popular statistical packages in use today. So you'll be able to find online resources, like tremendous amounts of online resources to help you with your SPSS. Now, we are going to go through everything that you need to do SPSS, to do the statistics that you are going to be asked to do in this course during class. But if it's 3 in the morning and you cannot remember how to do a particular t-test, and you cannot find the lecture or the lecture notes about how that, how to do that, just know that there are YouTube videos upon YouTube videos that will show you how to do everything in SPSS. So just be aware of that. Lots of help associated with this program. It is used extensively. All right. For our purposes, though, because we're just beginning out, we're not going to be using this dialog box, so we can close that up. And we get here to SPSS, and this is the main interface. This is the main window. Now, we have in this data editor here, there's two important views. There's your data view and there's your variable view. The data view is what it opens up default to. This works kind of like Excel. Many of the shortcuts, many of the commands are the same as Excel, but this is where you're going to enter in your data. We're going to see the variable view in just a second. That is where you kind of determine your variables, but we're going to start off with the data view. So we need to put our numbers into Excel in a way that, into SPSS, in a way that SPSS is going to understand. So to do this, we can go to Excel, and we are going to select the raw data that we want to copy and paste into SPSS. So all we want is the raw scores. We don't want the mean. We don't want the sum of squared deviations. All that we want is the raw scores, and we want all of the raw scores. So be sure that you highlight all of the raw scores. What we're going to do is once we've highlighted that, we're going to hit Control-C or copy. You can copy it using any way that you like. I like Control-C. So we hit Control-C to copy that. We go back to SPSS. We just click on column 1, row number 1, and then we can paste it. Either use the right-click paste or Control-V works also. But we want to copy and paste those numbers so that we have them in SPSS. All right, so has everybody done that? They have their numbers in SPSS? Okay. So right now it's not going to be too much of a help to us. But one thing that I'm going to remind you of, because it's going to help us immensely later on down the road, organizing your data in SPSS is oftentimes one of the biggest challenges to running your hypothesis test. And there's a number of different kind of tips in order to format and organize your data in SPSS. But by far the biggest and most useful one is that in SPSS, each one of these rows is reserved for one and only one subject. So each subject gets its own row, and each subject only gets one row. And that's going to help you organize as our experiments and data gets a little bit more complicated. That's going to help you organize your data a lot more effectively. So for example, we here have monkey number, let's go to monkey number 5. A little bit of monkey number 5. All right, monkey number 5, 15.3 hours spent with the terry cloth mother. Monkey number 5 gets row number 5. What that means is that if we were to measure every monkey's weight, that monkey number 5's weight would be entered in column 2, row 5. If we were to measure their height, monkey number 5's height would go in column 3, row 5. If we were to measure their eye color, it would go in column 4, row 5 for monkey number 5. Monkey number 5 gets the entire 5th row and only that row. So we can't enter monkey number 5's data into row 13. That's for monkey 13 if we ever got that many monkeys. So every single row in SPSS is one and only one subject, and it's reserved for that subject. And when we get into more complicated experiments, that's going to help you organize and determine where to copy and paste your data. All right, so we have our data pasted in there correctly. The last thing we're going to want to do before we choose and determine which hypothesis test we're going to do is we're going to change the name of our variable. So right now, SPSS has given our variable a name, and it's given it the name var00001. var00001 is a great name for a variable if you're a robot. All right, that is completely memorable and understandable if you're a robot. For us humans, var00001 is a horrible name. And if you were to walk out of this room for 15 minutes and engage somebody in conversation and come back, chances are you would not remember what var00001 scores were meant to be. So we need to change this for something that will jog our memory, that our human brains can understand. So to do that, we're going to click on Variable View. So go down and click that second tab. And this brings up the variables that we have. It's a list of variables that we have in SPSS. Now again, we're starting off simple. We only have the one variable, var 00001. So what we're going to do is we're going to click on that name there, and we're going to change it to something that just jogs our memory. And what I'm going to change it to is I'm going to change it to tear cloth. Now, I would love to change it to terry cloth, but I highly advise against that because SPSS, as amazing as it is, as wonderful as it is, it's in its 24th or 25th now iteration. It's had 25 versions. And those versions are built on top of all the previous versions. And when you build a program on top of all its previous versions, occasionally some of the idiosyncrasies that came along with prior versions will manifest themselves in your latest version. And if any of you have ever worked on a computer from the 90s, you know that back in the old days of computing, you could not name your files any length that you wanted to name them. There were limits on how long you can name your files. And typically the limit was 8 characters, right? These days you can name your files entire paragraphs. But back in the old dark days of computing, you couldn't. It was 8 characters or less. In SPSS, some places, that dark history still comes back, right? So that idiosyncrasy where you need to keep your names 8 characters or less still occasionally pops up some places in SPSS. So while I would love to write terry cloth, I'm going to not do that, and I'm going to write tear cloth instead, because tear cloth is 8 characters or less, and I know that regardless of where I go or what I try to do in SPSS, that file name, that variable name is going to be fine. So if you don't follow this rule and you name your variables longer than 8 characters, sometimes it's going to work. I'll be honest with you. SPSS doesn't care sometimes. Sometimes it won't work. All right. But if you name it 8 characters or less, guarantee you every single time it will work. The other thing I'll mention right now is that SPSS has some other throwback rules for naming variables that it will bring to your attention. So one thing, for example, let's see if it'll do that. Yeah, there we go. So I tried to name my variable 5 hours, just for no particular reason. But you can see here that SPSS has come back and said, no, variable name contains an illegal character. So just as you're learning SPSS, as you're kind of introing into SPSS, just be aware that you're going to do certain things that are completely fine for every other computer that you interact with, for every other program that you interact with. And SPSS is going to say, no, that doesn't work for me. So it's going to be a little bit frustrating. Just kind of roll with it. Very nicely, SPSS tells you what it doesn't like. It goes, variable name contains an illegal first character, because I tried to start my variable name with the number 5. So I'm like, all right, I won't do that. So we're going to keep it as tear cloth. So tear cloth, 8 characters. We go back, there it is, tear cloth right there. We got our numbers in. We are ready to go in terms of running our t-test. All right. So is everybody at this point? Okay. So now we're ready to run our t-test. The only thing we need to do is we need to tell SPSS to run that t-test. So to do that, we're going to go up to these drop-down menus up here, and we're going to go to Analyze, and we are going to spend our time in Compare Means. All right. So for the hypothesis test that we're doing in this course, we're going to camp out and compare means. As you can see, there is a ton of stuff that you can do with SPSS, but 90% of your time in psychology, you're going to be camping out right there on compare means. Now, we have a single sample t-test. That's what we want to do. And very nicely, SPSS has a test here called a one sample t-test, and that is the one that we want. So sometimes SPSS is going to be very friendly. And you're sitting there going, I need a single sample t-test. And SPSS is going to say, how about a one sample t-test? And you'll say, that's exactly the same thing. Sometimes it'll be nice. Sometimes it won't be as nice. This time it's being nice, so we're going to choose this. So once again, we go to Analyze. We go to Compare Means. We go to one sample t-test. We click on that, and then it brings up the dialog box. So this dialog box for one sample t-test is pretty straightforward. In this case, we only have one set of data, but if we had more sets of data, if we had the time that the monkey spent with the terry cloth mother, and the weight of the monkeys, and the height of the monkeys, and the eye color of the monkeys, we would have to tell SPSS which variable we wanted to run a t-test on. So in this case, we only have terry cloth, so we click on it, and we use this little arrow here to move it into the test variables. If you ever make a mistake and you move the wrong variable in, no problem, you can just move it back. You just move it in, move it out, in and out, terry cloth in, terry cloth out, terry cloth in. All right, so we want terry cloth. That's the test variable. That's where we have our raw scores, right? That's what SPSS is going to analyze. That's our samples score. The last thing we're going to do, and I'm going to make a big deal about this, because this is where students who make a mistake on the t-test, this is where they make the mistake. All right, so red flag, super warning everywhere. The last thing you need to do is you need to change your test value here to your hypothesized mean. To your hypothesized mean. All right, so SPSS is telling you in this dialog, you've given me all these numbers, terry cloth, right? You've given me the time that these monkeys have spent with their terry cloth mother. And by default, I'm going to compare that to a time of 0. So if you want me to tell you whether or not these monkeys spend more than 0 hours with the terry cloth mother, that's what we're ready to do, and SPSS is ready to rock and roll. However, our hypothesized mean, the worst whiteboard I've ever seen. Our hypothesized mean is not that these monkeys spend 0 hours with the terry cloth mother. It's that these monkeys spend 9 hours, right? 9 hours with the terry cloth mother, 9 hours with the wire mesh mother. So SPSS is all ready to compare the time that they spent with the terry cloth mother to 0 hours. That's not the test we want to do. We wanted to compare the time that these monkeys spent with the terry cloth mother to 9 hours, to our hypothesized mean. So what we need to do is we need to go into that test value and we need to change it to 9. It's a simple thing to do. It's a straightforward thing to do. Your test value has to be equal to your hypothesized mean. But I will warn you right now, whenever I see errors done in the single sample t-test, 99% of the time, it's the wrong test value. So please be sure that you're not doing everything correct and then forgetting to change that test value to the hypothesized mean. We're comparing terry cloth, how long they spent with the terry cloth mother, to our hypothesized test value of 9 hours. That has to be a 9 in there. All right, so everybody got this dialog box ready to go? They got the 9 in the test value? All right, we've set it up. We're ready to go. We hit OK. And in the blink of an eye, SPSS, boom, has calculated out the one sample t-test. So there it is. Pretty quick, pretty painless. All right. So let me see. Actually zoom on this. Nope. Zoom on that. Nope. Okay. All right. So this is the test output. Just very quickly check your numbers against these numbers here. So I'll explain what all of these are, but 9, 15.3, 1.73, 172, 3.638. Does anybody not have those numbers or like super close to those numbers? It's all good? All right, sweet. All right, so that is SPSS. It's crunched our numbers for us. Now what we need to do is we need to figure out what does that all mean. So we have our, there we go. So we have our SPSS, it's all done. It's run the statistics. Now what we need to do is we need to interpret that table, find the information that we need, and we need to decide whether or not to reject the null hypothesis. So again, if that sample t-score is beyond the cutoff t-score, we accept the research hypothesis and we reject the null hypothesis. If, on the other hand, our sample t-score is within the cutoff t-score, we accept the null hypothesis and we reject the research hypothesis. So we need to know where to find that information. So let's zoom in here and I'll point out where we can find everything that we need. So what we're looking for is we're looking for every step of our hypothesis test. So we are going to need to find information for step 2, which is the comparison distribution. All right, so we are going to need the degrees of freedom, and we are going to need the, no, just the degrees of freedom for the comparison distribution. No, we're going to need the standard error. All right. The estimated standard error as well for the comparison distribution. For step 3, we are going to need our cutoff score. All right, so what's our cutoff t-critical? All right, for step number 4, we're going to need our sample means t-score. All right, so that's all the information that we would normally have. That's what we're looking for. That's what we need to find. I can get a little bit more light on this. Not the board. No. Is that better or worse? Is that better? Better? All right, we'll do that. All right, so that's our missing information. It's all there somewhere, so let's find out where it is. Okay, so we're going to start off here in this top table up there. Now that top table, the first thing that we want to do is we want to just do a quick check to make sure that we did not mess up anywhere in terms of entering the data into SPSS. So you will be surprised how often you select and copy the wrong data. You miss a score, you add a score. You know, mistakes happen. So you want to take a couple of seconds and just double check to make sure that you have entered the right data. So SPSS very nicely says for that terry cloth raw scores, the number of raw scores you gave me is 9. And we just take a look at that and say, yeah, we had 9 monkeys. So far, so good. And SPSS will also tell you the mean of those scores was 15.3. And you can look at your Excel sheet or you can do a quick calculation in your Excel sheet and you can say, yeah, that's the mean you should have. So that double check just gives us confidence that we've done everything correctly. We've set it up correctly. SPSS has got all the raw scores correctly. So it gives us confidence to move forward. It also calculates out for us the standard deviation of our mean. So once again, you can do that in Excel, just a quick little check to make sure that you've entered in your data correctly. All right. The other thing that we want to check your test value. And your test value in this second table here, on that test value right there, your test value, again, should be your hypothesized mean. So our hypothesized mean was that the monkey spent 9 hours with the terry cloth mother. Our test value is equal to 9. That, again, lets us know that we didn't mess that up. We didn't forget to change that test value. We got the right test value for our study. All right, next thing. We have, for our comparison distribution, we need the estimated standard error. That is listed in SPSS as the standard error of the mean. So we've calculated this number out previously, that 1.73. We've seen it before, but now SPSS has done it for us. So this estimated standard error, this comparison distribution's estimated standard error is 1.73. So we have that from SPSS. It's done the heavy lifting. It's done that calculation for us. We also need degrees of freedom for our comparison distribution. Remember that in a T distribution, the shape of it changes for the degrees of freedom. And if we look at our SPSS output, we got degrees of freedom right there. Now it's simple enough to say, oh, we got 9 subjects. 9 minus 1 is 8 degrees of freedom. But make sure also that you get into the habit of double checking with SPSS, because degrees of freedom for some of our hypothesis tests can get a little bit complicated to determine those degrees of freedom. So it's nice that SPSS did it for us right there, 8 degrees of freedom, step 2, finished. All right, so that's step 2. Step 3, we need our cutoff score or our T critical. That SPSS will not do for you. So step 3, the cutoff score or critical value, we still got to look this up. So you'll still need to go to your textbook, go to that appendix, look under a T score or a T distribution with 8 degrees of freedom, and find that critical lines in the sand, find those critical values that you can use to compare your hypothesis test to. We are going to be making a slight switch for that in the very near future. But for right now, we still need to look it up. SPSS will not calculate that out for you. We need our samples t-score. SPSS will calculate this out for you, and it will give it to you right here. So remember before when we used to take our sample mean and subtract away from that our hypothesized mean and divide all that by the standard error of the mean? Well, SPSS has done all that for us, and our t-score for our sample is 3.637. So what that means is that we have on our comparison distribution, our sample has come in at 3.637. So normally we would take that sample t-score and compare it to our cutoff scores. And in your homework, you will take that sample t-score and compare it to your cutoff scores. But I do want to give you a way, and I do want to show you a way to do a hypothesis test without having to look up those cutoff scores, without having to go to the back of your appendix and look up those cutoff scores. And the way that we're going to do that is by taking a look at that two-tailed significance right there. So this is going to require a small little change to step number 5. So we're going to use that significance two-tailed. We're going to use that probability of 0.007, and that's how we're going to make our final determination. You can do it using the sample t-score and the critical t-scores, but if you don't have access to the table, or this is the way that we do it in real life, we're going to be using the significance two-tailed, this p-value here. So normally we would say if the sample t-score is beyond the cutoff t-score, we're going to accept the research hypothesis and reject the null hypothesis. If, on the other hand, the sample t-score is within the cutoff t-score, we would accept the null hypothesis and reject the research hypothesis. We are going to do the same logic, but instead of using the cutoff scores, we're going to use the probabilities. So instead of what we've been doing so far, we've started out with the probabilities. We have an alpha of 0.05. We have a two-tailed test, and then we look up the cutoff scores. Instead of doing that, we're going to cut out the middleman, and we're going to use our p-values that SPSS calculates for us, and we're going to use the alpha directly. So instead of using the alpha to find cutoff t-scores, we're going to use the alpha directly. So our cutoff probability score is going to be that alpha, and in this question, it was 0.05. All right? That's our cutoff probability score. And we are going to have our p-value, and our p-value is going to be compared to our alpha that was given to us in the question. And if the p-value is less than our alpha, we are going to accept the research hypothesis and reject the null hypothesis. This p-value gives us the probability that our results are due to a wacky sample. This gives us the probability that normal monkeys do not prefer the terry cloth mother over the wire mesh mother, but we just happen to have 9 terry cloth mother-loving monkeys in our sample, and they were weird, right? That's the probability that that p-value is. So we're going to accept that. We're going to take a look at that p-value, and if it's less than the alpha, we're going to accept the research hypothesis and reject the null hypothesis. If, on the other hand, it's greater than the alpha, if the probability of our of getting these results just because of our sample is greater than our alpha, we're going to accept the null hypothesis and reject the research hypothesis. So you can see that the logic is very much the same. If this occurs, we accept the null hypothesis. If the other thing occurs, we reject the null hypothesis. So we go back to our significance two-tailed. That is our p-value right there. So it's 0.0007. To get scores this extreme, just because we chose a weird sample, this probability is saying that would only occur 7 in 1,000 times. So we have less than a 1% chance of picking monkeys this weird, right? So it's a 1% chance that our results are due to us picking weird monkeys. That means it's a 99% chance that our results are due to the fact that monkeys prefer the terry cloth mother. So in statistical kind of jargon, this number here, this probability, is less than our alpha. This is our probability line in the sand. Because the probability from our t-test is less than the probability of our alpha, we reject the null hypothesis. And again, until that is absolutely clear, refer to these slides here. So if the p-value is less than alpha, 0.007 is less than 0.05, we're going to accept the research hypothesis and reject the null hypothesis. If it was the other way around, we would accept the null hypothesis and reject the research hypothesis. As it stands, our p-value is less than our alpha. This is where we find our p-value right there. So our p-value is less than our alpha. We reject the null hypothesis, and we conclude that the monkeys actually do prefer the terry cloth mother. If you want to double check this, and I encourage you to give it a shot, take this t-score that SPSS has found, look up our critical scores, and you should come to the same conclusion. So doing it by probabilities gives you exactly the same answer as doing it by cutoff scores, because cutoff scores are directly tied to the proportion in the tails. Proportion in the tails is directly tied to probabilities. So this is just a new way of doing. We're going to slowly transition into this way of doing it. But this allows you to make your conclusions completely from the SPSS output. So before we wrap this up, this is the way that we do it, or that I do it, and most of the faculty here will do it when they're running their statistical tests. However, for your homework, it will still ask you for your cutoff, for your sample score, and it will still ask you for your cutoff scores. So when you're doing your homework, just be aware that SPSS does not give you the cutoff scores for your t-test. You will still need to open up your textbook, look at those tables, look at the appendix, and zero in on those cutoff scores. All right, so once again, because we were set back a little bit, I have yet to update the MyStatLab study plan. I will get to that as soon as I can. I'm still trying to catch up on things from that week. But stay with it. If you're not getting 100% on your pre-tests, make sure that you're doing the mastery points to get those 100% points for your pre-test from the MyStatLab study plan. And then what we have right now, I know we only got about 10 minutes left, but there are practice problems. So in the Excel sheet, you will notice that there are additional sets of data from other for other questions. So there are extra practice problems here so that you can practice your t-tests. The descriptions for those are in a separate, they're in a separate PowerPoint file. So when you open up this practice, it goes 21 practice, October 30th, PowerPoint file, it'll give you the question that gives you all the information to figure out your hypothesized mean. It will give you the SPSS output that you're looking for as well. And it'll also give you the step-by-step for all 5 steps of the hypothesis test, answers for what's the null and the research hypothesis, what's the mean of the distribution of sample means, what's the estimated standard error, what's the degrees of freedom. Basically, every step along the way, it'll give you those answers for the extra demo questions. So I would highly recommend, give those questions a try, practice this a little bit. All the answers are there. Try to work through the whole thing before checking the answers, and that will be your way of kind of practicing this before you actually do your homework. So that is all that I wanted to cover for today. So before we end today's class, just want to mention that the due dates for the homework have been moved to accommodate this week that we missed. So do check the updated syllabus. Do check the MyLab. Things have been moved back a little bit. But as it stands right now, you do not have homework due for next class. So I would highly, highly recommend, because this is your intro to SPSS, try these practice problems out, work on them. We got about 10 minutes left if you want to start now. But definitely do these, check them out, make sure that you're getting the right outputs, make sure that you're interpreting them correctly. And when you're ready to start your homework, I think we got one more thing I want to cover before you're ready to go. I highly, highly recommend that you use SPSS as much as possible to do your homework. So again, you have access to SPSS at home, open it up, put in the data, run the statistics, because while you can do the homework by hand, practicing it with SPSS is going to be so beneficial, especially when it comes time to the exam. Because if you're very proficient with SPSS, it will take you absolutely no time to do the calculations for the exam. And then you can just kind of sit back and spend your time looking at the numbers in the tables and determining what your conclusions are. So put in the time, get quick with the SPSS, get fluid with it. It'll pay you back tenfold for the exam, and also for later to get this proficiency with a statistical package. All right, other than that, we are done for today. So again, if you want to give it a shot, feel free. If you want to call it an early day, feel free as well. But it's good to